Yo, what is up, guys? Welcome back. Trying to see if I'm live right now. We're gonna have issues. I've been trying to fix my OBS. I think we're good. Trying to see if I'm live right now. We're gonna have issues. I've been trying to fix my. But yeah, we're live. So let's take a look at some problems today. Whoops. Why is this? Yep, there we go. Let's grab a tab over here really quick. Alright. I think we're good. I think we're good with the stream too. For some reason it's working today. Yesterday it wasn't. I don't know why, but yeah, we're gonna take a look at some problems. So on our Linux boot today, so probably no C++. I guess we can take a look at this one. Daily problem today. 1695 maximum erasure value. You're given an array of positive integers nums and want to erase the array containing unique elements. The score you get by erasing the subarray is equal to the sum of its elements. Return the maximum score you can get by erasing exactly one subarray. To be honest, I'm not really too sure what that means, but let's copy and paste the nums here. Get it on our screen here. So we've got our nums here. You're given an array of positive integers nums and want to erase a subarray containing unique elements. Erase a subarray containing unique elements. The score you get from erasing the subarray is equal to the sum of its elements. Okay. We're given positive integers and want to erase a subarray containing unique elements. So we want to look for a subarray that contains unique elements. So I would assume, 4, 5, 6. 2, 4, 5, 6. That is true. Right here. The score you get by erasing the subarray is equal to the sum of its elements. So then we would just find the unique subarray and then grab its elements. Return the maximum score you get by erasing exactly one subarray. And array B is... So we want to return the maximum score you can get by erasing exactly one subarray. Right. So we get 521 here. So I'm thinking straight away, the first thing I think here is definitely a sliding window. I'm like 99% sure the way we want to solve this problem is with a sliding window. That's what I'm thinking. Reason is that we can have our left pointer here, right? We can have our right pointer here, looping, right? As we add values. Right? And then we would move our left value by 1, right? Every single time. But the thing is how do we want to keep that? I'm sure we could probably use a set, right? Instead of a hash map to store our values. So I'm thinking a set as well. Hash is equal to set. Right, we can have our left pointer here. This is kind of happy because I kind of wanted to do a sliding window problem, so I'm a little bit happy about that. Dude, shit, my knee hurts like fucking bad, dude. My calves, bro. So how do we want to implement the sliding window? Well, we can probably do it in many different ways, right? We can probably use a for, right? That's kind of the usual way I like to implement it for right. For right in range length nums, right? trying to guess here. We could potentially just use a while here and just loop through all the values until we find one that's inside of set. What is that? Technically a sliding window? I don't know. Maybe not, but I mean, who really cares? I guess if we solve the problem, we solve the problem, right? I guess now we think about it, we should probably look at the constraints. So we're going to 10 to the power of 5, so we're going to need a somewhat fast solution. I'm going to kind of start with the way that I was suggesting. So what can we do here, right? We can do... So we're at right. I always get the implementation for a sliding window, dude. It always fucks with me. I think I'm overthinking again, dude. That's my issue. I fucking overthink all the time. All right. While right, not... While right, not in hashy. I guess while, sorry, nums right, not in hashy. We can keep moving. So, right in range length, while nums not in hashy, we can... What would we want to do here, right? We probably... Every single time, we probably want to set our hashy. We want to reset our hashy. I guess we're redeclaring it here, but... we could loop through. While num's right, not in hashy. We can... I guess add num's right? Hashy.add num's right. Right, so now we're gonna start by looping every single number while num's right, not in hashy. Let's do like... This is not really a sliding window, I think. This is more of a... Now we're thinking of it more of a... Yeah, I guess we're solving a brute force right now, dude. Low key. While nums I, hashy.add nums I. Let's think about this, right? The way that we're doing it, right? We have our right pointer here. And our left pointer here. We're adding, and then we're moving right, and we're adding. That's not gonna work, yeah. This isn't a sliding window, dude. Need to figure out what the... So we have our hashy, we have our left. Good evening, mate. Sammy Daya, how you doing, bro? Good to see you again. Good to see you too, bro. I guess we were thinking about it the right way while num's right, not in hashy. Sorry, yeah, I guess while num's right in hashy, we don't want to check that it's not in hashy, because we want to check if it's in hashy, because if it is in hashy, all right, let's think about here. Let's create our hashy here for this first loop, right? We're going to loop through. We're going to do while num's right in hashy. What do we want to do? I guess we want to do... let's think about it here. Let's do it with this example, right? We're going to add 4. We're going to add 2, right? Then we get to 4, right? Okay, we haven't added it yet. We're going to get to 4, and we're going to see, well, now it's true. Well, num's right in hashy. Num's right is in hashy. So what are we going to do, right? We're going to do... how do you index a... Can you index a set? I don't know. Can you index a set in Python? I have no idea. It's been a while. Use a for to raise the variance. Checking for element existence. You can check in keyword. Okay. Sequence for ending. I don't think you can index a set. So, I guess what would we do here? Maybe... Can you please explain the problem statement once? Yeah, so this is our problem here. We got 165, just the daily problem on LeetCode, 165, 1695, maximum erasure value, right? So we're given an array of positive integers nums, and we want to erase a subarray containing unique elements. The score you get by erasing the subarray is equal to its sum of the elements. Return the maximum score by erasing exactly one subarray, right? So we're given this array, and what we want to do is we want to find all the subarrays that are unique. So for example, in this example here, we have 4 and 2, which is unique. It wouldn't be 4, 2, 4, because then we'd have 2 4s, right? 2 4s would not be unique, right? So we have 4, 2. We have 2, 4, right? We have 2, 4, 5, 2, 4, 5, 6, right? And so our answer here would be 2, 4, 5, 6, because this subarray has all unique numbers, and then we would just take the sum of it. So 6, 11, 17, right? And we would return 17. It looks like we got our output as 17 here. Does that make sense, Samidia? But I'm thinking here now, maybe a hash isn't the way to go here. Well, I do think still a hash is the way to go, but what I'm thinking here is that I would use like sum in some way, and I don't think we would sum. Because I don't think that would work. Yes, mate. Yes, sir, bro. Yes, sir. So, yeah. So I'm thinking, dude, maybe we should have cosum and then a max sum, right? I guess we would set this max sum to like, I guess we can set it to like float of negative infinity, right? I guess. We loop, right? We get to our while here. We have while num's right in hashy. Then what would we do? We would go cosum minus or equal to num's left, right? And then we can go what else would we do here? Cosum. We would increase our left by 1, right? And I guess we would remove it from our hashy too. So hashy dot remove num's left, right? Then we continue outside of this while. This is where, okay, if this doesn't exist, what would we do? Well, we would probably add to our cursum. So cursum plus or equal to nums right. Hashi.remove. Hashi.remove. I guess we can do nums right here. That would probably be the way to go. Oh no, we would do left here, right? We wouldn't want to remove nums right. We would want to remove our left value, right? Because then we're increasing it by 1. But then if it still exists, we want to keep going. So I think, yeah, we would remove our left here. Here we'd add nums right, and then we do cursum plus or equal to nums right. And then we'd probably take the max here. So we do what maxsum is equal to the max of maxsum cursum, right? And then we just probably want to return maxsum. Let's see what that returns. We get wrong answer. Damn, dude. We're like totally off as well. So I'm not thinking about it right. I do think I have a good idea about what's happening. I guess we can run through this, step through this code, I guess, right? So here we have 4 right in range length nums. We're gonna just do this test case here, right? While nums right in hashi, right, that won't exist. We're adding cursum twice. Why are we doing that? I just noticed that. Okay, maybe that was our reason. No, we got 21. Okay. Yeah. Oh, we're forgetting. I just realized we are not adding it to our hashi. Hashi.add nums right. That could be our issue. Okay. So we're expecting we got 15. In this case, we pass. So we're missing something here. Let's take a look. Let's step through, right? So we start off with our left is equal to 0. We loop through with our right. Okay, hashi.add nums right. Okay, so let's add our nums right. We did. We increase our cursum. Let's do our cursum here, right? We can have our max sum over here, right? Our cursum would be nums right, so this would be 4. And then we take our max, right? And then our max sum would be 4 as well, right? Go to our next value. So now we're looking at 2, right? We would add 2, right? It's not going to enter this while. We would hashi.add nums, so we added that, right? Cursum, this would go to 6 now, right? And then this would go to 6. Simple as that. Now we're at 4. This is where we'd enter this while loop here. While nums right in hashi, what do we want to do here? Cursum minus or equal to nums left. So we're going to drop this to 2. We're going to increase our left by 1. So now our left is pointing here. And we're going to do hashi.remove nums left. We remove our hashi from here. So now we only have 4. Then we can see, obviously, this while loop doesn't pass. That while doesn't work anymore, right? Because we removed the 4. Sorry, we're not removing 2. Oh, shit. No. I got rid of my code, dude. No way. Oh. What did I miss here? Hashi dot add nums right. Damn, bro. Let's go back. Okay, so we're back at 2 again. I fucked that up. I'm gonna mess up my head, but okay. So we're back at 2 now, right? We added 2. We increased this to 6, right? That's our current sum. Our max sum now is 6 as well, right? Now we go to 4, right? We see that 4 enters our while, right? We remove this one. Well, actually, no. Let's go in order here. We cursum, right? This goes to 2. We remove, and then we increase our left by 1, right? So our left is pointing here, right? Then we would add Indian Bai. Hi, bro. What's up? Hello, dude. How's your day been, bro? Hi, Aman. What's up, dude? Thank you guys for jumping in the stream and coming to hang out. Just doing a little bit of DSA. Doing our daily problem today. Trying to debug this in our head probably isn't the best way to do it, but I mean, it definitely isn't the best way to do it, but anyway. Yeah, now we want to add this, right? So we add our 4, right? So now we got our 4 here. We do cur sum, we're back to 6 now, right? We take our max sum, it stays at 6, right? Then we go to 5, right? We are not going to enter this. We would add 5, right? So now we go to 11. This would go to 11. And our cur sum would have 5. Then we go to 6. This would go to 17. This would go to 17. And we move here. That's weird, because I returned 17. But we get 15 here. So what the fuck are we doing, dude? I feel like we're thinking about it right. We have the right logic, but... Oh, our max sum is float infinity. Is that... Wait. Negative infinity. No, that's fine. Comes right in hashy. Yeah, guys, I don't know. I don't know what I'm missing here, to be honest. Does anyone see what I'm missing here, dude? This looks fucking good to me. It's something fucking stupid, I feel like. Let's put this in, what is my bug? What is my bug? This is where you need a compiler, dude. You can step through it. Bro. What's up, Samidaya? Oh my god, dude, that's my issue. I'm incrementing left before I'm removing it, dude. That's why I should have followed it in the way that I had the code. Is it really that hard to get a job after learning programming? Try to remove from hashy at the starting of the while loop. Yeah, I believe that was my issue, Samidaya. Is it really that hard to get a job? I don't think it is, to be honest. I haven't been looking for jobs yet. So, I'm still a student. I don't do this again, like, I mean, I've said this multiple times, like, I don't do this series to, like, get attention, to get a job or anything like that. Like, I do this more because, like, I actually love, like, computer science. Like, I love it so much, and I just love programming. So, like, doing these leak code style problems is just, like, fun to me. Like, just, you know, I don't know. I generally enjoy just doing it. I'm going to be looking for jobs, like, this is my final semester coming up here in the fall here, so, hang on one second. Turn off my timer. Okay. Yeah, I'm coming up to my final semester here, so I'm going to start applying here. Probably in a few weeks, I'm going to start my application process and everything for a job in January, so I don't know. I'm pretty confident I'll find something. It's just kind of hard to get an interview, I feel like. Definitely, it's kind of hard to... Because there's so many people applying, you know? I mean, there's thousands of people per job. Like, it's kind of insane, but I think I'll find something, so... But point is, I just love doing these videos, and I just love programming, so that's why I enjoy doing it. And it's easy to stream these sort of problems, because anyone can catch along, you know what I mean? Like, got my working out here, people can read the problem, you know, everyone can join in, you know, so it just kind of works out well. Yeah, that was a good problem. This is such a weirdly worded problem. Should I leave a comment here, dude? Goated problem, bro. Let's go. Let's go, dude. But yeah, let's jump into another problem. Open my Discord here. I plan on, hopefully by the end of this week, I'm going to start working on my C++ game here on stream. That's the goal. I'm kind of just setting up the project right now, and again, I'm pretty new to C++, so it's been a little bit of a learning curve, but yeah, I'm excited to do that on stream here in a few days, so that'll be fun. You're learning a lot. Let's go to 11 here. Prime pairs with target sum. Take a look here at this problem. 2761 prime pairs with target sum. You're given an integer n. We say that two integers x and y form a prime number pair. If 1 is less than or equal to x is less than y is less than n, x plus y is equal to n, x plus y are prime numbers. Okay, return a 2D sorted list of prime number pairs x, I, y, I. The list should be sorted in increasing order of xi. If there are no primes, number pairs at all, return an empty array. A prime number is a natural number greater than 1 with only two factors, itself and 1. Okay. Let's take n is equal to 1 here, right? Figure out what we're going to do here, right? So we're given an n, and we say two integers x and y form a prime number pair if 1 is less than or equal to x is less than y is less than n. X plus y is equal to n. X and y are prime numbers. So there's multiple things we have to do here, right? X, y, n, x plus y is equal to n, x and y are prime numbers. The list should be sorted in increasing order of xi. If there are no prime number pairs at all, return an empty array. A prime number is a natural number greater than 1 with only two factors, itself and 1. Okay, so... This is tough here because you have to think about it in pairs, right? So I guess, you know, we have our int n is equal to 10, right? What are we going to do here, right? We're going to keep checking 1, 2, 3, 4, 5, right? If it's prime, we're going to keep going up. We're going to see 3. We're going to have to store 3 as our x value. And then if we don't have a y, we're going to have to add on x5, right? But then as well, we have to think of a way, well, you know, what if 3 would never work, right? What if like a 5 and a 7 would work, you know? So we have to think about that, but I'm kind of not sure how to think about that, to be honest. I'm not even too sure about how to calculate a prime number, to be completely honest. Pre-compute all the prime numbers using a sieve. Store them in a data structure where they can be accessed in all one time. Fuck me, dude. That is so smart. How did I not think about that? You hate Python, is that it? I've never really heard of this algorithm. Sieve of Etrathenesis is an ancient algorithm for finding all prime numbers. Oh wait, I've looked at this before. I'm just not sure what the... let's think about here. Like, what sort of data structure do we want to hold this in? I'm thinking maybe a set, right? Probably a set is the way to go. One, because we know we're not going to have any duplicates, right? Because we're going to loop through all our prime numbers, right? And we're going to add our prime numbers. So like 1, 3, 7. Is 1 even a prime number, dude? I don't even know. Is 1 a prime number? No. Okay, never mind. 1 is not a prime number. All right, so we're going to have 3, 5, 7, right? Up to 10. So what? We're never going to have a duplicate, right? So that's why I think a set will work. We can access them in all of one, right? So we get our set, and then we can probably just loop through our set and just try all the combinations. I think that's probably the way to go. The thing is I'm not kind of familiar with this algorithm. That's the issue. I don't really know. I guess we're probably going to have to kind of look this algorithm up a little bit. Sieve of eratosynthesis. How to apply in Python. Because I'm not sure mathematically how we can look for a prime. Holy fuck, dude. That's a lot of fucking code for a fucking prime number. Maybe we can watch a video on this algorithm. I'm sure there's probably a video. Yeah, let's take a look, man. I haven't looked at a video like this.
I knew I was underwater. I just didn't realize I was this underwater.
Oh my gosh, dude. Hardcore E-Ray, bro.
I've had several requests to show the workings of the sieve of Eratosthenes. So here goes. It's an ancient Greek method of finding prime numbers in an array or the hundreds chart. It was created by Eratosthenes, one of those Greek mathematicians from way back. We can use this to identify prime numbers up to 100. The following steps will help us find the prime numbers.
Up to 100?
Start by crossing out the number 1. Do you know why we cross out the number 1? Any takers?
It's not a prime.
Well, it's because a prime number is any number greater than 1 and only divisible by itself and 1. So 1 cannot be a prime number because it is not greater than 1. Okay, now let's put a circle around the number 2. It is a prime number because it is greater than 1 and is only divisible by itself and 1. 2 is also the only even prime number. Next, we'll cross out all multiples of 2. To find the multiples of 2, simply skip count by 2. For example, 2, 4, 6,
What's up,
8,
Shahid?
10,
Nice to
and
meet
so
you,
on.
bro. Croat or Serb? I'm Croatian, dude. Well, my dad is. I was born in Australia. My dad's Croatian, and then I was born in Australia. He immigrated to Australia, and I was born there, and then I live in the United States, so...
Did you notice any patterns for the multiples of 2? You do realize I can't hear you. They all end in 2, 4, 6, 8, or 0. So if a number ends in 2, 4, 6, 8, or 0, then one of its factors is 2.
No, I can't speak, bro.
Next, let's put
Can't
a circle
speak Croatian,
around
dude.
3.
I wish.
It's a prime
My
number
dad and my
because it is
grandparents,
greater
my
than
whole
1
family
and
knows
is
how to
only
speak,
divisible
bro, but
by
I
itself
can't speak,
and 1.
so...
Next, we'll want to cross
No,
out
dude,
all the
I don't.
multiples of 3. To find
Sorry,
the
bro.
multiples of 3, you can skip count by 3.
Are you Croatian, dude?
For example, 3, 6, 9, 12, 15, and so on. You'll notice 4 is already crossed out. That's because it's already a multiple of the prime number 2. The next unmarked number is 5. I'll just place a circle around the 5 because it is a prime number. Next, let's skip count by 5s.
I
Do you
understand what's
notice
going on
any
here.
patterns in the multiple or hopes number is not a prime 2 and 3? All the multiples of 6.
So is prime. Is prime 0 is equal to is prime 1 and 0 and 1 are not primes. Start at 2 while p times p is less than or equal to n if p is prime p. Ugh, shit, man. Okay, let's go ahead and implement this algorithm, right? So probably the way we want to go about this is probably want some helper function, like let's do find primes, right? Right. Let's pass in like, no, it's perfectly fine that you do not speak I am Croatian. That's cool, dude. That's awesome, dude. I generally wish I could speak, bro, but I can't, dude. But it's whatever though. I wasn't interested in learning when I was younger, bro. I just like my dad tried to teach me or whatever, but I guess when I was younger I didn't want to learn. So I guess it's not really too late to learn, but I'm just like too busy nowadays to learn, I guess. I should learn though. Honestly. Okay, so how do we want to implement this algorithm? Right, so say 1, so 0 and 1 is not prime, right? It's hard to speak if you didn't grow up with it. Python is easier. Yeah, bro. Python is easier. Python's easy as fuck. I don't even really do much in Python, bro. Literally, all I do in Python is leak code problems, dude. Just because it's like so much easier to code in Python. Like, it's insane. And also, like, I don't know. I've been solving these in C++ too. These problems, but you know, I don't know. Just I have to. For me to solve them in C++, bro, I need a debugger. Like, I cannot stand debugging C++ in a with no debugger. Fucking doing it in this shit. You gotta pay $30 for a LeetCode's debugger, and it's just like kind of AIDS. So is prime is equal to true times what? N plus 1, right? Then we want to set is prime 0 is equal to false, because is prime 0 and 1 is false, right? Shit, what did this guy do here, bro?
Any taker visible by greater than 1. Okay, now let's put a circle around the number 2. It is a prime number because it is greater than 1 and is only divisible by itself and 1. 2 is also the only even prime number. Next, we'll cross out all multiples.
I thought we had to make 2 prime. Okay, so that's what they do here, right? N plus 1. P is equal to 2. Well, P times P is less than or equal to N if P prime P. So if it's true, mark all the multiples of P as non-prime. Prime I is equal to false. So we start with 2's, right? And then what are we doing? Where mark all multiples of P as non-prime. Again, like, I don't think, like, knowing this really helps at all, but, I don't know, I guess it's probably a, oh, dude. Do they do anything? They don't set anything to false, do they? No. Okay, I guess maybe not. Maybe I'm tripping balls. Maybe you don't need this. Okay. Set p is equal to 2, right? While p times p is less than or equal to n. 2 times 2 is 4, less than or equal to n, yeah. If prime p. So if it's true, like all multiples of p is prime. Okay, well if prime p y in range, we start at p times p, start